All right, so we've just completed chapter 4. Now we're about to start chapter 5, which you can see is on systems of equations and inequalities. So up to this point, we've done a lot of work with learning how to solve equations and inequalities. So in chapter 1, we did the most work on this. We learned how to solve all kinds of different equations and inequalities. And then we came back to this in chapter 3, where we looked at polynomial and rational inequalities. But we didn't go into these types of equations because we learned how to solve polynomial and rational equations in chapter 1. But then in chapter 4, we were introduced to a brand new expression type, or two new expression types, the exponential and the logarithm. And so with that, we learned how to solve exponential and logarithmic equations. Now, we didn't get into exponential and logarithmic inequalities, and I think this is because the way that the textbook is, the authors are teaching this, is they feel that, so with everything we learned about solving inequalities in chapter 1, combined with what we learned about how to solve polynomial and rational inequalities in chapter 3, that should be enough. What we learned in those sections should be enough to, if we ever came across an exponential or logarithmic inequality outside of the course or the textbook, then we know enough to kind of put 2 and 2 together on how to solve it. So we didn't go into a section on an explicit section on exponential and logarithmic inequalities. Okay, and that's really it for the course. We're not going to be introduced to any more new expression types. So we've learned everything we're going to learn about solving equations and inequalities in this course. And so now in chapter 5, what we're going to look at is the idea of solving systems of equations and inequalities. So what that means is we're thinking about how can we solve, for example, 2 equations at the same time. I don't know if that's the best way to say it, but the idea is, so, okay, let's write one equation here, and we're going to write, it's an equation in 2 variables. So the most general way I could write this is, let's put, one expression of x and y on this side, and another expression of x and y on this side. So this is completely general, right? You could put some expression of x and y. You could put logarithm here, an exponential or polynomial, whatever, some combination, anything with just some expression with x and y over here, and then another expression with x and y over here. That's an equation in 2 variables. Okay, but now let's go ahead and write another one of these equations below it. Okay, so now we've got 2 of these equations, and what we want to think about is, what if these equations were like coupled together, and we wanted to solve them simultaneously as a system? And so what that means is that we want to find some point, I'll say x naught, y naught, some ordered pair, that if you plug it into this equation, it satisfies the equation. So you plug it in, simplify, you get like a number is equal to another, that same number. 3 is equal to 3, for example, whatever. Then you plug that exact same point into the other equation, and it also satisfies that equation. So it satisfies both equations at the same time. If you plug it into this equation and it satisfies it, a certain point. You plug a certain point to this equation and it satisfies it, but you plug that same point to the other equation and it doesn't satisfy it, then you haven't solved the system of equations. Okay, now this would be called a system of 2 equations and 2 unknowns. But you could also think about the idea of solving a system of, let's say, 3 equations and 3 unknowns. So you would have f(1) x, y, z, g of 1 x, y, z, and you would write out 3 equations like that. f(2) of x, y, z, g2 of x, y, z, f(3) of x, y, z is equal to g3 of x, y, z. So you have 3 equations and 3 unknowns. And in that situation, you're looking for a x naught, y naught, z naught, that you plug it into each one of those equations and it satisfies all 3 of them at the same time. And, you could change this to, instead of an equals, make it, and inequality. And you have three separate inequalities. Same idea. But you could keep going. You could do 4 equations and 4 unknowns, 5 equations and 5 unknowns, or 5 inequalities, 5 unknowns, whatever. Now, but you might be saying, but okay, every example that I just gave was like the same number of equations and unknowns, right? So but couldn't we, what about something like, you know, f1xy here we've got 3 equations and 2 unknowns. Or, the kind of the other way, you could say, what if we had 2 equations and 3 unknowns? Well, yes, we can. When it comes to simultaneous equations or inequalities, we can look at all scenarios in full detail. And that's actually something we really look at in detail in linear algebra. However, in this chapter, we're just getting our feet wet with systems of equations. And all we're going to look at is what you could say are symmetric systems, same number of equations and same number of unknowns. And in the opening 2 sections, we're going to start with the simplest type of equation, the linear equation. So systems of linear equations. We're going to look at 2 equations, 2 unknowns. Then in section 5.2, we're going to look at 3 equations and 3 unknowns. And then in section 5.3, we learn partial fraction decomposition. And I believe the reason why we wait to learn this here, you might wonder, well, why are we learning that at this point in the course? Because with partial fraction decomposition, you need to, in most cases, a lot of cases, you need to be able to solve systems of equations. And it's nothing too complex, but like systems of 2 equations, 2 unknowns, or 3 equations, 3 unknowns, to get the constants associated with the decomposition. And so until you learn how to solve systems of equations, you can't really do partial fraction decomposition. Okay? And then in section 5.4, we're going to look at the idea of 2 equations, 2 unknowns, but the equations aren't linear. And then in section 5.5, we're going to extend the idea to inequalities. And, you might say, well, aren't we going to go into systems of nonlinear equations in 3 variables? And here it just says inequalities and systems of inequalities in 2 variables. Or we're not going to go to 3 variables. Well, the idea is, no, we're not. But you could go on forever. Why don't we learn about in 4 variables, 5 variables, 6 variables, 6 equations, 6 unknowns, 6 inequalities, 6 unknowns. And then, okay, if we're going to study nonlinear equations in 2 variables, we're going to have to study every single type of nonlinear equation that we would be here forever. So the authors we're going to learn enough here to where if we had to solve, a system of 3 logarithmic equations and 3 unknowns, we know enough to where we could maybe right at the moment, we don't exactly know how to solve it, but with a little bit, maybe you go back to your algebra textbook and you just think about it a little bit, and there's enough, you've learned enough to where it's the same, it's just a simple extension of the ideas that we learned here to solve that kind of equation that we didn't explicitly study, that kind of system of equations that we didn't explicitly study, right? It's the exact same idea we didn't study an exponential or logarithmic inequality. However, with what we learned about how to solve polynomial and rational inequalities, it's going to be it's the exact same idea. You're going to bring all the expressions to one side of the inequality. If we had exponential or logarithmic expressions, all of them to one side with the other side 0, then look at that expression as a function that's equal to 0 and find the intervals where that function is greater than and less than 0, and that solves the inequality. Right? So there's no need to go into solving exponential and logarithmic inequalities. It would have been too much. Okay, so yeah. Now let's get started with chapter 5.